Good evening. In this video, I'll discuss about unit root testing using aTSA package. Though I have already described about unit root testing applying T-series package. In this video, I'll explain how to apply Augmented Dickey Fuller Test or stationary test in RStudio with the help of aTSA package. Basically, this aTSA package gives more robust result compared to T-series package for unit root testing. So let's discuss how this result will be explained. I have the data set of 5 stock exchanges like Mexico, KSE and others. I will apply unit root testing on Mexico dataset. So first and foremost, I have to install and keep it in library, and that is of aTSA package. I have already installed this aTSA package, so simply I'll load it in library with the help of writing library aTSA and then enter. Now this aTSA package is loaded in library. Okay, after that I simply write here stationary.test and then Mexico and enter. Well, it gives more robust result in 3 different aspects, like type 1 no drift no trend, type 2 with drift no trend, and type 3 with drift and trend. Basically, this result is a little bit similar with eView's result in terms of 3 different aspects. Well, now the question is, which will be best as per these 3 different methods? If you think in your data set there is no drift, no trend, then you can follow this result. If you think your data set has drift but no trend, then you can follow this result. And if you think if your data set has both drift and in a trend, then you can follow this result. So you can see with the help of plot.ts, and then accordingly you can go for this stationary test. Let's suppose in this data set I assume that there is drift but no trend, then I can follow this result. Now the question is, what are these? Basically, this 0, 1, 2, 3 and so on up to 7, these are nothing but number of lags of Mexico, and obviously these value are ADF value, and finally these value are P value. Here the question is, which P value we have to consider. In this case, basically we are supposed to consider the last one, because last one here up to 7 lag. It simply means in my data set the optimum lag for testing the stationarity is 7. So as per that, P value is 0.265. It means this is greater than 0.05 So what is null hypothesis in this case? Null hypothesis is Mexico is non-stationary series, or it has unit root. It means my null hypothesis is accepted. So I can say that the Mexico series is non-stationary series. By default, when you run this stationary dot test, it gives the Augmented Dickey Fuller Test. Now I can also write here simply adf.test and then Mexico and enter. The similar result you can find. It means in this aTSA package there is no difference between this adf.test command and stationary.test command. So that is all about how to test stationarity using or applying aTSA package. Thank you very much.